Hi friends, today we are going to discuss introduction to linked list. The linked list is a non-primitive linear data structure. It is a linear data structure. Okay, for better understand, we discussed in previous class, that is classification of data structure. See here where it comes. Okay, the classification of data structure. In this data structure we are concentrating on linked list where it comes. Okay, in the classification of data structure, linked list is a non-primitive linear data structure. Okay, linked list is a non-primitive linear data structure. Okay, here we have n number of linear data structure: arrays, stacks, queue, and linked list. Okay, here next is the linked list is a dynamic data structure, and the size of linked list can grow or shrink. Okay, here the linked list, the size of the linked list can increase or decrease. Okay, next point, the elements of linked list are called node. Each node will contain two different fields. Okay, it will contain two different fields. Okay, first one is data field and second one is the link field. Okay, just I will write it one diagram here. Okay, it will contain two things. First one is the, here we'll have one node structure. Okay, first okay, first box will contain data field. Okay, first one will contain data field and second field will contain link field. Okay, total this we are going to call it as a node. Okay, total this we are going to call it as a node. Okay, understood, right? Here linked list we are storing data in the form of node. Each node will contain two things. First one is data field and second one is the link field. In the data field we are storing actual data, okay, or information. In the link field it will contain the address of the next node. Okay, in the link field it will contain the address of the next node. Okay, next point, the linked list insertion or deletion of nodes at any point is allowed. Okay, we can perform insertion or deletion at any point. For example, in the beginning of the list or end of the list or specified position, we can perform insertion and deletion operation. Okay, next point, the random axis of elements is not allowed. Okay, in the linked list, okay, it will contain list of nodes. For example, this is one node, again we'll have next node and third node. Okay, for example, random axis of elements, for example here we have third node. If I want to access directly third node, it is not allowed. Okay, that is the next point. And here we have, here we listed some advantages and disadvantages. The advantages are dynamic data structure. Already I told you people, linked list is a dynamic data structure. Why we are calling dynamic data structure? In the sense, okay, in the linked list we are allocating memory space at the runtime, so that we are telling it is an dynamic data structure. And next advantage here is efficient memory utilization. Why? Because it is a linked list is a dynamic data structure, so that we are using memory efficiently. Okay, next third one, easy of insertion and deletion operation. In the linked list we can perform, okay, insertion and deletion operation very easily. Okay, that is the third point. These are the some advantages of linked list. Next, the disadvantages of linked list are random access is time consuming. Already I told you people, here it will contain list of nodes. Okay, this is first node and second node and third node. If I want to access third node, it will time consuming. Why? Because we need to traverse from the beginning, first node, after that second node, after that third node, so that it is a time consuming. And next disadvantage here is it requires more memory space. Why? Because, okay, why? Because in the node it will contain data field along with the link field, right, or the address field. Okay, here if I want to store data along with, we need to store addresses also, so that it will requires more memory space. Understood, right? Very simple. Okay, with this we are completing this introduction to linked list class.